what we will talk about today is how to actually deal with a complete provider failure. Now, what we wrote is not the piece of code we wrote is not only about cloud specifically, but it's actually any provider failure. But we will talk about cloud, and you'll understand why in a second. So there are two issues that we want to cover today, and one is the regulatory issue, because basically working in FSI, obviously a lot of the changes that banks are enforced to do are actually regulated. So someone is coming down and say, all right, now you have to deal with this. And the second part will be the technical issue. So why did we make the choices that we did, talking about this regulatory issue? So the problem with the cloud adoption in FSI is that more and more banks are going to the cloud now, because nobody really wants to go, to the counter to do their to deal with their accounts. So everyone wants to go to the cloud, but one of the issues is that most of those banks are choosing the same cloud provider. So we're in the phase of a big cluster risk. So if everyone goes into the same cloud, what happens if that specific cloud provider goes bankrupted, or I don't know, there's a political problem, or there is war, or there is an economical crisis? Obviously, the impact of losing multiple banks at the same time is something that we really don't want to deal with, because the global economic system can be heavily impacted. Now, obviously, with this cloud adoption, regulators are coming with a lot of different ideas on how to avoid this cluster risk. So obviously, at the beginning was just data privacy, and now we start to talk about operational resilience. So what does operational resilience means? Means basically, how do you do you have an exit strategy if something major happens to your infrastructure? So how can you recover, and how fast can you recover from a major failure? So Europe has been leading the charge here with this regulation that is called DORA, Distributed Operation Resilience Act. Operational Resilience Act, and obviously there's England also is following along, following along as Canada did, and basically it's moving with different names on the same direction everywhere. We want to be sure that our bank accounts are safe if something terrible happens. Basically, what they really want to do is managing third-party risk. So they don't want the bank to have a major vendor lock-in. They don't want to have a concentration risk, as I just explained. They don't want cybersecurity issues. So basically, what they want to achieve here is actually protecting the financial stability of a given jurisdiction. So in the long-term focus of it is provide digital sovereignty. So this means that every country can deal with the data in their physical jurisdiction. But what they want to avoid at a very short time or time span is actually that something very bad happens if one infrastructure goes down. So what is the technical issue here? So why is everything afraid of this move to the cloud? So we shouldn't forget that, and I mean, here we're more or less so technical. But we shouldn't forget that using cloud means that we're using someone else's hardware. So it's not ours. We're renting that hardware. Being cloud native and adopting the cloud provided services, which is great, obviously, in terms of operational practicality, it makes us platform dependent because most of the tooling that we use, for instance, with the AWS, are not portable on, say, Azure or Alibaba, Ali Cloud. So we're basically looking at a vendor lock-in that nobody really understands as such, because everyone says, but I'm in the cloud. I'm using this this service, but they don't think about the fact that their CI/CD now uses a language that is probably proprietary or a software that is probably proprietary, and they cannot bring it back to their own. So if you want to move back, or you want to move to another cloud, you have to rewrite the entire software. This is also very common with our ISVs. They tend to use the same application and reshape it for Azure, for AWS, for GCP, whatever, using whichever tooling the cloud provider is using. This obviously is a pretty big problem. The other thing is, but they don't have the feeling to be vendor locked in, but it is what it is. The other problem is that if you use their data storage service, your data are actually physically handled by a different company. So you're not handling your data anymore. You're asking someone else to keep it for you. So that's why, for instance, I mean, now it's changing a little bit, but if you look at the costs of taking those data back, so downloading data are much higher than uploading those data, because everyone knows that data is the new oil. Another thing that is often overlooked is the fact that multi-region is not really multi-region for everything. So for instance, if you take data, normally you don't have data replication across multiple regions. You need to use different services to do that, which are normally very slow, very prone to failure. Say, I don't know, AWS EFS is distributed, but it's basically a glorified NFS. It's not really a very bleeding edge software. So, and it's pretty slow, and it's not really kind of modern, but it's the only way you have to distribute those data across multi-region. So even though you are multi-region, your data might not be. So that is actually something that is pretty critical. So a lot of, I mean, the more I talk with the people, the more ask back, like, is this even a possibility? Because it sounds a lot like a zombie apocalypse scenario. And this is exactly what we want to talk about today, because it can be like a flood. And I mean, we have extreme events very often. Now, obviously, it's not going to crumble tomorrow, but it can happen, right? Because you can have power failures. Now, we've seen also, like, for instance, in the UK, when basically the internet wasn't working because of on a malconfiguration, and this led to massive downtimes. The cloud provider company can retire a service. I mean, if you rely on a service and that service is no longer in use, then you cannot use it anymore, and they can bankrupt. Now, I mean, of course, those are giants, but I mean, we know that is possible. That is a possibility. Obviously, the most or the one of the the aspects that are unfortunately very unpredictable is actually politics. So what happens if you are on, I don't know, a specific cloud that is based on a specific region, and the region in which you work from declares an embargo, like a digital embargo. So you cannot use that cloud service anymore. So how do you get the money, the data back if they're all there? So you will have to go through a lot of political issues before you can actually get those data back. Obviously, war and other problems can also be part of what we're looking at. That's why I put the Fallout Boy in the slide. So how did we approach this issue? So we knew that this was a possibility. We have the tooling to do it, and we wanted to cover the most possible, the highest possible number of cases in which this would work. So we approached the solution in and divided the problem in three major kind of steps. One is the crawl status, the other one is the walk status, the other one is the run. For now, we did the crawl status. So what we did, even though it is mature enough that has been integrated as the basic toolkit for our validated pattern, it is still in a walk state as a solution, like as an holistic solution. So what were the crawl requirements? So first of all, we want this to be based on OpenShift because obviously one of the biggest issues was banks are going to the cloud and are working FSI. So and most of those banks, they're writing software that is now being containerized. Even though, I mean, obviously, some of them have a more kind of lift and shift approach. Some have like a more kind of rewrite it from scratch approach. But they are all moving towards containerization. So being for banks, or mainly for banks, so the solution is not only for banks, but it's just the way we looked at it. We wanted it to be able to handle policies, because policies are very important for banks. The application, we assumed that for now the application runs on a single OpenShift cluster, and we're also, one big assumption, and I know that this doesn't make the solution perfect, but is a starting point. We're assuming that what is failing in this scenario is the cluster and not the cluster hub. So ACM will stay. For those who don't know ACM is a software that runs on top of OpenShift that helps operational groups to handle more OpenShift. Another thing that needs to be clear, and this I got a lot of questions when I was at Summit, so here I wanted to kind of say it in advance. ACM should run on a third location or cloud provider. The second cluster, so the cluster in which we're trying to kind of move the application to, can be already there as a hibernated cluster, or can be created. In the example and in the demo that I will show, which is actually a video, it's not a live demo, obviously, to reduce the risks of it not working. In the video, we will be showing a cluster that is hibernated. Obviously, having a cluster hibernated doesn't add a lot of costs because it's all the resources are kind of on hold, but they're not working. So, and the failure domain is the cluster is gone. So think about, you have a data center, this data center gets flooded, and you have a massive power failure. So the cluster is not there anymore. We're not trying to fix the cluster. We're trying to get away from that cluster. So in the video that is about like between 3 and 5 minutes long, the first thing you will see is that we installed the pattern. The pattern is installed through Ansible. It will create the hub cluster, and then it will install everything else. Then OpenShift GitOps will do all the magic. OpenShift GitOps through ACM will install all the operators. It will configure Submariner, which basically is the plumbing between the two clusters. And it will set up everything ready for the application to fail over. Now, there is one important thing, and it is this box that you see on your right, which is the fact that whoever is running the application has to tell which disks are failing over, so which data are failing over. That is the only thing that we expect from an operational perspective on the application that is running. Now, most of this was already there. So, but there was one specific tool that we were missing, and it's the regional DR trigger. So we wanted to have something that was fairly automated. So who is looking after the clusters, and who is realizing that the cluster is broken, and who starts everything, who kicks off the failover. This is the regional DR cluster, and this is what Alejandro Villegas and Tomer Fingerblatt have created for us, and I take the occasion to thank them. I know that they're in the call, and they did an amazing job here. I know that they were busy also with tons of other stuff, so I'll take a moment to kind of recognize their effort. Obviously, the backup is done using OpenShift Data Foundation with their DR policies. As I said, the plumbing is done through Submariner. And another important thing is that here we're talking about active passive. There is only one cluster running, and then we fail over to a new one when it dies. So the application only runs on one cluster effectively. So this is what we've done till now, and what do we want to do next is basically elevating this validated pattern into having into consuming an hybrid cloud model, as in the application is running on 2 different clusters on 2 different cloud providers. We want to also add the complexity of having a old school database. By old school, I mean a relational database. The one that we're using is MongoDB. MongoDB is not a relational database, and it's already distributed, but it's not what we see the bank using. Bank usually use either Oracle or Postgres. We want to have a 0 RPO RTO pattern, so we want to have an active-active scenario. We want to make sure that there is no failover. We want to be sure that the application is always running. Obviously, we want to further automate everything, and what we are looking for is a database that is capable of multi-region replication. Been talking with Oracle about this. They say that they might have a solution. I've been talking with Yugabyte, which is basically based on PostgreSQL, and the reason why I was talking with Oracle and Yugabyte and not CockroachDB, because we know that CockroachDB is capable of doing this, is because we don't want to have it too niche, because banks are a bit are a bit resistant to adopt very new technologies. So I'll be showing the demo. And for the demo, I chose to use a very mission critical application. This application is a Pac-Man game. What you will see is that while we're playing Pac-Man, Pac-Man fails, the cluster fails, and we're able to continue playing with the same score on the next cluster. All right. So as you can see on the top, on the right side, we have a shell. So this is the commands that you need to do to give to your whatever jump post or whatever to have everything installed. And here on the left side, you see a OpenShift cluster. So now we install the pattern. The command is pretty simple, pattern make install, and everything starts. So this is, again, for the ones who are not familiar with it, this is Argo CD, which is the upstream. I mean, it's basically OpenShift GitOps that is based on Argo CD. And this is everything that gets installed through Argo CD, which is really the core of what happens on this pattern. So this is the regional DR pattern. This is what it contains. All the type of bits and pieces that are needed for the pattern to work. So we select it, and then it will be installed. Now everything is synced, as you can see on the sync status. The app health is still degraded because it's being deployed. Now the two clusters are created. So here you can see the local cluster, which is basically our hub cluster, so ACM. You can see the primary cluster and the secondary cluster. Now, those are standalone clusters, so they're not either ROSA or ARO. But just for you to understand what we're doing, this cluster is actually in Europe, EU Central 1. The other cluster instead, it will be in North America. So we have, West America. So we have one cluster that is in Europe, another cluster that is very far away from it, and they're both healthy, and they're connected by Submariner. So basically, we have these two clusters. They are running. The networking is connected between the two using Submariner. The data are being synced between these two clusters, and there are like the DR is being set up, and all of this is completely automated. So there is no interaction. So this is all done. So as you can see here, now our application Pacman is being installed on one cluster. The cluster is the application is running on the OCP primary cluster. That is the one that is in Europe. As I said, we have to tell which disk do we want to prepare to have a copy of. So here's what we're doing. This is just for for nerdiness. Basically, we're showing that we did it. So here now you can see the application placement. So where the application is running, and you can see namespace is Pacman, the air placement control, blah blah blah, OCP primary, failover cluster of OCP secondary. The state needs to be relocated. So we have a primary and a secondary cluster. So as you can see, there is no resources in the secondary managed cluster. Now we're playing Pac-Man, which is really mission critical. We're making some score, and we save it. This is basically the same stuff that happens when, for as funny as it sounds, as when a banking transaction happens. So at a certain point, the transaction is done, someone has to commit it. And all the transactions in banking are always saved at the end. Otherwise, they roll back. That is usually the behavior. So as you can see here, player one has a score of 900. Now, here, this is AWS console. We are destroying the cluster. It's not really destroying, but we're stopping all the instances. Now, our little piece of software is watching for the status, and it found out that something is wrong. So as you can see here, the primary FSI partner cluster is down. So here, the persistent volume is being recreated, and Pac-Man failed over. Now, the application has been failed over. The cluster here is being replaced under the hood by a third cluster. So this, as I said, the cluster that is lost forever. We don't want to fix it. We will create a new one. And if you can see here, this is the second cluster. Player one has still a score of 900 points. So basically, the application has failed over successfully, and the time that we had to wait was actually just a few minutes. Just the time to spin the cluster, move the data, and have it fixed. Any question?
There were several questions in the chat, Andrea. I'm not sure if you want to go through those. We do have other people answering and asking questions.
All right.
It might be worth it just to talk through them if you'd like.
Yeah. Yeah, David, sorry. Well, can you, no, I don't think you can see my monitor. We link the slide in the docs. Feel free to ask questions. Any plans? Any plans to test with two ACM controllers? Yes. This is basically the work requirement. So the next step will be using two ACM. And obviously, it's still tech preview, but this is where we want to go. We want to have Bruno, the entire system to keep working, obviously.
Yeah.
Yeah, go for it.
Yeah, no, it's fine. I'm happy with that first set of questions.
Of what disk to fail over requires a bit of manual action. Obviously, this can be automated by whoever is running the application, but it's something that has to happen on the customer side of things. And yeah, as Alejandro actually just answered. Another question from Bruno. Any plans to allow the ACM automation to trigger a deployment pipeline hosted outside of ACM hub? As Alejandro said, we don't know if integrating external pipelines is possible yet. We will have to test it.
Yeah, I think just especially on this point, it's probably not uncommon for customers to have built their own stack or using a cloud provider stack if they're on the cloud. So I guess the trigger needs to be under ACM control, but then the steps you get through to fetch the image, maybe do some other prereqs like I don't know.
Yeah, there are certain ones around that, because basically if you use a cloud provided service for your CI/CD, then you don't have the CI/CD on the other. If you're in an hybrid cloud scenario.
Yeah, but I guess it's a question that probably will come up, especially for customers using cloud. So knowing if we could trigger something that already exists is probably a useful thing.
Yeah, I mean, we just need to kind of figure out how best to address this, because as I said, one of the main issues is the fact that it might not work, because if you have like two different CI/CD, then the trigger has to change.
It's just related to this, again, in terms of automation, the traffic is being directed to the active OpenShift cluster. There's a failover. You get it into get all the applications running on the secondary cluster. Could be useful to have some sort of extension or guidance on how you can also automate the switchover, for example, with external DNS record to point from cluster on region 1 to cluster on region 2. And I guess with Ansible playbooks, you probably have automation that could go and update the AWS name service or Google.
I mean, also, and you can use also stuff like F5 service discovery or other things. This really depends. It is infrastructure dependent. I was actually this morning I was in the Ansible Automate show here in Zurich, and I was talking with the guys at F5 to kind of experiment a bit with this.
Yeah, I mean, you obviously there's quite a lot of different services. I'm just thinking from, I guess, capabilities out of the box. If there is an assumption that the customer using the usual suspects, the native service from AWS, Google, or Azure, which you probably have playbooks for that, having some sort of option to have this automation out of the box, maybe it's good. Or maybe with someone like F5. I don't have. I get the point that probably doesn't. There's so many permutations that it's hard for us to support it, but could be useful also to think about 1 or 2 or 3 examples maximum that we could have pre-baked automation.
Yeah, I'm not sure what I'm.
There's an operator. Can you hear me, guys?
Yeah.
Yep. There's an operator really useful for this kind of scenarios. It's provided by Red Hat, and it's called the external DNS operator. And its purpose is basically to doing some DNS tricks, balance the traffic between 2 clusters. It's not included on the path, but that's one of the, let's say, preferred solutions, for doing this kind of.
Okay, so it may be the case if that stuff already exists, making that just documenting it as a possible solution.
Yeah, probably we could try to include it on the pattern itself. I threw the link about this operator on the chat. But yeah, by the moment we were focusing on the most important part, maintain the storage synchronized.
Yeah, no, I get it. But it's useful to know that I didn't know that this operator existed.
Yeah, there are already solutions for doing that. We simply need to choose one of them.
Yeah. Okay. Great. Thanks.
Again, I want to take some time to say thank you to Tomer and Alejandro that have been like definitely the most important people in here, because they did the job, and actually they also did the video. Thanks a lot to you guys again for all the effort.
Thanks everyone. It was a pleasure.
Any other question? We still have.
I guess the last point that I've also put on the chat was any plans to look at the hosted control planes angle?
Look at what? Sorry.
Look at look at the hosted control plane. So the pattern has been designed and proven for failing over from OCP standalone primary cluster to a standby cluster. What if you now have a few clusters on one region? Maybe they are managed through hosted control planes. Would this pattern work with hosted control planes where you have region one with an HCP hub that manages, I don't know, 3 or 4 or 5 OpenShift clusters, and then you have on another region, again, HCP running the backups 3, 4, 5 clusters, and then kind of scale. Probably also an interesting capability for our customers that are running OpenShift at higher scale.
Yeah, I mean, there's there's a lot of stuff that is still missing before we arrive at kind of scenario. So, that definitely we will have to have a look around both in terms of application failover, service discovery, hosted control planes, ACM.
Andrea, sorry, can you repeat? We couldn't hear you. There was some background noise.
Sorry, Valentina, I did not get.
Yeah, so there was some background noise. If you can repeat, we couldn't hear you.
Yeah.
The last like 10 seconds. Yeah, thank you.
Okay. Yeah, I mean, what I was saying is there are tons of different scenarios that are not covered in this scenario or in this pattern. We're still in the crawling phase, so we will have to kind of discuss what to do in the walk and in the run, and all these things like service discovery, automated failover, active, hosted control planes, failure of ACM, and all this kind of stuff. We need to kind of still sort it out basically and give it priority and see what's going next. I think one of the most important thing for the moment is actually testing this pattern with a real database. I mean, I don't know, like if it's for lack of better terms, but a database that actually people in FSI use. So Postgres or Oracle. Oracle has been at Summit told me that they have a sharding mechanism and another software is called Golden Gate. I have no idea what we're talking about. I'm never been a database guy. But, I guess I have to speak with them and figure it out.
Yeah. My thoughts here are more around things like MQ in Kafka, things that would require persistent storage, traditional disk storage. I think that the databases is always a special case, and I don't know. And this is a question for everyone, that I don't know how many clients we have running large databases on OpenShift. And if they are not running on OpenShift, then it becomes more of the typical workloads that you definitely need persistent storage. That would be things like MQ streams and MQ broker as an example, or just file-based type of applications. I'm personally working with an FSI client that has a bunch of apps that are being slowly modernized, and they are very reliant on just file transfers from one place to the other. So the failover scenario here is based on just traditional disk storage. So this pattern is definitely very interesting.
One of the main challenges here is that usually it's not a great idea to use a relation, like classical relation database on OpenShift or in Kubernetes in general, because databases are meant to scale up, and while any clustering application, really, not only OpenShift, is meant to scale out. So it's kind of an anti-pattern. Now, obviously, so we assume that when you use a Oracle database or something, you have it outside of the cluster. Though this raises even more questions in that sense, right? Because like then who takes care of the database? Then, you know, because for banks, usually banks, they don't store a lot of data on a disk level. They have a ton of data on the database because everything is a relation. So hence I want to talk with Yugabyte because they have something that is distributed. I've been like the feedbacks that I had for Yugabyte weren't, they all said that the performance weren't great. I haven't seen it, so I can't really comment on this. I know that Cockroach can do it. I know that NuoDB can do it if still exists, but it could do it. But unfortunately, like it's a fact that banks mainly use Oracle and some of them uses Postgres. So it's a bit, I think that we should focus on something that is stuff that people really need, as we want to be like an example on how to deal with these kind of issues.
Yeah, I was mentioning the just traditional disk because you will see a good amount of customers that still move files around as a way to get applications to exchange information. So databases, yes, definitely, that's big relational databases, but file-based stuff, it's also common. I want
From the
to
pattern
ask,
perspective, every application which uses persistent volumes is
yeah,
switchable to be included here and to be failed over, because we are not looking
yeah,
for disks or looking for files. We are looking simply for the persistent volumes that the applications
yeah,
are using.
exactly. Yeah, which actually leads me to my last question. You may not have looked into this, but in theory, would the persistent storage that is managed by ODF, would ODF be interchangeable with things like, I don't know, Portworx or NetApp, which are common partners of us that work in the storage virtualization space?
You mean about the protocol for connecting with ODF?
Or replacing ODF even?
No, ODF is mandatory in this setup
Is
because we
mandatory.
are
Okay.
using some specific features about ODF.
Okay.
Yeah.
All right.
What
Thanks
we
for
could
clarifying.
provide also is like an S3 endpoint for accessing the ODF storage system and taking the data from the volumes with that protocol, which is more flexible. But ODF, at least by the moment, is mandatory.
Okay.
Yeah, I mean the one of the issues, and I mean I've been working with distributed file systems for a while. One of the main issues when you deal with file systems is that there is no standard to kind of address this stuff. While basically databases are by family, so if you're SQL compatible, you have kind of the same language. With distributed file system, you don't. There was last week there was a OpenStack community forum that is called Open Infrastructure Forum at CERN. And when I graduated at CERN, and they still have some of the stuff that I was working on that was prior to Ceph, because basically they don't have any way to translate it. I wasn't aware of this. I just learned it today because I was talking with one of the guys that was there. And I mean, unfortunately, if you take, for instance, the block storage migration tooling of VMware, I'm sorry for the ones who are probably not super technical, but if you take the tooling from VMware and you want to move it to Ceph, you have to do some kind of conversion, and normally a lot of those conversions are destructive. So there's a lot to unpack, unfortunately.
All right. Thank you.
Any other question?
This has been great, Andrea. Thank you so much for presenting, and everyone who contributed to this. I know you have Alejandro on here and others that were included in preparing this material, but this was fantastic. Thank you.
Thank you. And
Thank you so much.
just for the last 5 minutes, also want to take a minute to say thank you to Adrian Hammond that coached us through the technical requirements, and Monica Sasso that took care of the regulatory bits that are always very important to learn. And obviously also to our partner Temenos that kind of instigated the entire thing. So yeah, thank you guys, and yeah, hopefully I'll see you next time.